видеть. И вам спасибо за участие тренинга второго дня. Сегодня у нас в преподавателе также Старк. Тогда мы начнем. Старк, 那你开始吧。
好，那就现在开始。
嗯。
Okay, let's get started. And today's topic is about the solutions in the power utility and the oil and gas. First, I will start from the substation automation system. Nowadays, more and more countries are willing to upgrade their substations, their traditional substations, their legacy substations to a modern and new substation automation system according to 61850 requirements. And according to 61850, the substation is divided into three levels. The top level is station level, and then the bay level, and then the lowest level is the process level. And there will be two, and the Ethernet switch will be the communication medians between the different levels. So there will be three levels and two Ethernet network between the three levels. So it is three levels and two networks. And within each network, the network design should be the parallel network, LAN A and LAN B, for the full redundancy. And according to 61850, the capability between the different vendors should be ensured. In this way, the customers can build more flexible substations with different vendors in it. And except for the network requirement, since many of the substations are the high voltage substations, so it has many hardware requirements in the, for the devices which installed in the substations, which covers from the high availability and the high ENC level to resist the electric and magnetic induction. And also, the devices should have need to operate at wide temperature range. And also IP40 protection should be essential in the substation. And also the devices need high accuracy tie synchronization based on RB and PTP. And for the software requirements, 61850 MMS should be supported on the devices for the centralized monitoring. Besides, according to the 61850, the IEC 62439-3, PRP and HSR and RSTP are two recommended redundancy protocol for the substation. Besides, the cybersecurity features are more and more prioritized in the substation design these days. And the following, I will introduce some KYLAND solutions for the substation. The first one is the solution fully comply with the IEC 61850. You can see that there are three levels: process levels, bay levels, and the station levels. Actually, for the different levels, there are two networks between the three levels. For the two networks, actually, you can use the same switch. In this solution, we can use the SICON 3028 GPT or SICON 3024P. They are all suitable for the substation automation usage. And you can see that for the network, we use dual independent SICON 3028 GPT to create to create LAN A and LAN B. And the protection relays, base controllers, module units, and intelligent breakers are all already PRP supported. So our switch only just need to transparent the PRP tagged packets. And we don't need the additional PRP modules to be installed in the switch. But there is a difference in this network. In the network between base level and station level, there is a little difference. Although the protection relays and base levels, base controllers has already PRP supported, but the workstations and the servers, they are not PRP supported, since it is just some simple commercial use computers. They are non-PTP supported. So we need to use the red box or the PRP modulars installed in the SICON 3028 GPT to help these devices to support the PRP function. So here you can see that we have an additional red box or switch here. This is the overall of the network. And also we can provide our intelligent gateway here, since normally the network, the protocols inside the substations are based on the IEC 61850, but the network outside the substations, they normally are based on the IEC 60870 and 104. So you need to convert convert between two protocols. Here, a gateway is essential. Besides, we can also provide our tie synchronization solutions here. For the 3 levels, different accuracy are required. According to 61850, the substation level requires the accuracy around 1 second, and the base level requires the accuracy around less than 1 millisecond, and the process level required the accuracy less than 1 microsecond. So for the station level, we can just use NTP to synchronize workstations and the servers. But for the base level and the process level, we should use PTP and PTP or IRIG-Bs to synchronize the devices. Our PTS time server can provide all kinds of solutions above described. And this is another solution. You can see that this one is a new substations, or the customer fully upgrade according to 61850. But sometimes the customer do not want to fully upgrade. They just change some devices in the old substations. So we can provide this kind of solutions. You can see that some parts are the smart substation design, and it is based on the PRP network. But this part, it is still using other redundancy protocols, such as RSTP, such as DT rings, DRPs. And here we provided the DHP protocols, which is a private protocol of KYLAND, and it can guarantee the recovery time less than 20 milliseconds, and it has 2 links for the upgrade. And 1 link will be forwarding status, and another link will be the blocking status to achieve the redundancy. Besides, this is a network design, and for the tie synchronization, we can see that here is a GPS antenna here, And on this GPT, it is installed with a time server module. So it means that the time server module is connected with the antenna, and this GPT can synchronize other devices with the PTP protocol. Besides, you can see here, there is another PTP import here from the internet. So these two PTP imports will negotiate with each other by the BNC mechanism in PTP protocol, and a better signal import will be selected as the master and then synchronize the whole network. And another highlight is that you can see that most devices are already PTP supported, but here still some IEDs and module units are not PTP supported. So we can use a time converter to convert the PTP signal to the IRB signal and finish the last mile synchronization. And since many substations are the high voltage substation, so there is higher hardware requirements for the devices in the substations. You can see that here is a KYLAND certifications report, KYLAND certification report, and you can see that in the according to the test, the KYLAND switch can normally operate in a wide range temperature from -40 to 85, and also the switch is IP40 protection design. Besides, the ENC emission class is class A, and it can be used in the high voltage substation. Additionally, the switch has passed all the ENC tests here. Here is the IP protection of the KYLAND switch, and you can see there is no any heat emission hole on all the panels. So it is IP40. And this design sometimes is very useful in some applications. Later, I will explain to you. And this is another highlight of KYLAND switch. And we have supported IEC 62439 zero packet loss PRP and HSR protocol. And in this demo, you can see that we use the computer to check the real-time value on the IP camera. And all the string will and the camera and the computer are connected on the interlink port. When the interlink port receives the data from when the interlink ports receive the data, and it will duplicate to LAN A and LAN B. So it means that on LAN A and LAN B are two same packets. If there is a single failure, on LAN A or LAN B, it will have no influence on another LAN. So it will ensure the zero packet loss. It is a demo in 2019. It's a road show in the Asia Pacific area. You can see that we use, we are checking the videos in the IP camera. And if we disconnect one LAN, it still shows a smooth live video stream on the computer. And another highlight is that we have already supported the hot swappable power source on Silicon 3028 GPT. You can see that on the front panel, there are two hot swappable power modules here, source 1, source 2. And if I disconnect one, if I plug out one power source and continuously pin this device, you can see that in this period, there is no packet loss. With this function, we can easily fix the power source failure in the substation and do not influence the normal operation in the substations. And for the time synchronization, our time server and Ethernet switch have already supported the hardware-based IEEE 1588 PTP and version 2. And we have supported the boundary clock and the transparent clock. Also the peer-to-peer and the E2E version in the transparent clock. They are all supported. And the synchronization precision can be less than 100 nanoseconds. And you can see that this is a screenshot from the tester. You can see that the average accuracy is 66.5 nanosecond. Besides, in the substation, according to IEC 61850, it designed according to the IEC 61850, an additional network management language is introduced. It is MMS packet, and you can see in the substations there are many real devices, and the first step is to virtualize the real devices into a logical device. And in the logical device, there are many logical nodes. And then we will map the values, such as the current status, the voltage status, to the logical node, and then upgrade and then update these values while the TCP/IP network to the SCADA system. And this is a screenshot of our MMS status. And you can see that it is real-time status monitoring while IEC 61850. And the APST means the port 2, and now the port 2 is link up. And the speed is 1 gigabyte. It's working at the 1 gigabyte speed. And the out and the input packets here, and unicast packets, and the multicast packets count, and the broadcast packets count. It all can be displayed while MMS packets. Now let's go for the cybersecurity. KYLAND has already supported many cybersecurity features on the switch. First is user control. And now we have supported 5 privilege levels for the users. You can see here, we can set different privilege for different users, such as I'm on-site engineer and I will be the administration level. And the customers will only be set as a guest level, and they cannot modify the configurations and cannot perform other things. Besides, we have supported the strength or password-based authentication. And you can see here, this setting means that if I tried the wrong password for 3 times, then the switch will be locked for 3 minutes. This will resist the potential potential attack from some network attacks. And we also supported some user ID and authentication based on based on access control list, and remote access based on radios and TACAs. Also .1x based on ports. This is some introduction about radios and TACAs. Actually, user control are divided into two parts. There are two ways for the user control. One is local control, and another way is remote control. You can see that this is the NAS. This is the remote user. If I want to access this NAS, if I use local control, then I just send the username and the password to the NAS, and the NAS will verify the username and password locally. But if I use remote control, then I will send the username and password to the NAS. Then the NAS will forward the request to the radios and TACAs server. The radios and TACAs server will centralize to control the user access of the whole network. It will verify the password for the NAS and control the access of the whole network. Next, it is the event logs. You can see this is the event log from our KYLAND switch, and the information is very complete. You can see this is the log levels, and this is the time, this is the switch name, this is the switch type, and also the log details. All the modification on the configurations will be saved in the login informations. You can see here someone creates a new master domain name and ID will be saved here. And this is the system integrity. We also did some tests at the China state grid, and this is a test report. You can see according to the test that the source code inspected with integrity, and there is no malware found in the switch. And this is the data confidentiality and the restricted data flow. And we can use the SSH, SSL, and the SNMP v3 to achieve the data confidentiality. And we can use VLAN to get the virtualized segment on the switch. And we also have some private functions to support the anti-attack. To support the anti-attack. Now we have supported the DOS attack, ARP attack, and LRTP attack, and the foreigns. And this is also a report from China state grid. And you can see that these tests are all passed here. And another thing is that we have the additional network management system to cooperate with the Ethernet switch and monitor the whole network. The switch can send a real-time alert while the SNMP protocol and the network management system can vice versa pouring response while SNMP, Modbus TCP, and Ethernet IP, and of course 61850 and MMS. And here is the resource availability. Now all of our switch has supported the dual system imaging. You can see that there are two images in the switch. If there is one failure, and another will still take a role and be activated. And all our switch have supported the dual power module. And another 63028 GPT has support the whole swappable power module. And following, I will show you, give you some case show. This is a case. This is a project in Thailand state grid. You can see that this is a five-year roadmap. Start from 2018 to 2022. And in this roadmap, they are willing to upgrade all the substations to the smart substations. Since that is a big project, and the customer gathered all the vendors from the IED and the switch together, and they asked us to do the real pre-test in their office. So this is the topology of the real test. You can see the test is almost the same topology as a real substation. It has a process level, bay level, and a station level. And between these levels, there are two networks. And in these two networks, there are parallel network, LAN A, LAN B, and also LAN A, LAN B for the station level, LAN A, LAN B for the process level. And also there is a red box here. Since the HNI do not support the PRP protocol, then we will add a red box here to duplicate the packets to the PRP-A and PRP-B. And here you can see there is some pictures in that test. And here is our GPT, SICON 3028 GPT. Here is a red box. And the customer is doing the test using the Wireshark. And they are verifying that whether it is zero packet loss. In that test, there are many IED vendors. There is Schneider, ABB, Alstom, and many China companies involved in that project. So we also have many tests with these vendors, and they also most of them used our KYLAND switch to cooperate with that device in the substation. So we had many competitive tests on the PRP and the HSR protocol with the device. We tested with Schneider, ABB, Alstom, and Nanri, CYG, Sifang. Also, there is a vendor. There is a supplier. They are the distributor of Hushman. So they built the network with half of KYLAND switch and another half is Hushman switch. So, and in the end, they will connect with each other. So they also, so it is also fully tested in this project. And we also provide some on-site support at the commissioning stage. You can see that here is some pictures. And here, more pictures. And I go there since it is at the period of the bursting of the COVID-19. So we should wear the mask, and together with with our distributor in Thailand. And here are some recommended products here. SICON 3024P and SICON 3028 GPT. 24P is the most popular and economical switch from KYLAND. And 28 GPT is the most functional, plentiful, and it can support different kinds of modules. And both of these two modules are KEMA certificated. And then it's a red box used in this project. And the red box is hardware-based PTP supported. And the time synchronization precision can be nanosecond accuracy. Also, it is KYLAND certification. It has KYLAND certification according to IEC 61850 and IEEE standard. The ports are combo ports design. You can see these three ports, and these three copper ports, and these three fiber ports are combo port design. And there is another management port here. Besides, it also can support the code box mode. And the following is the Thai server recommendation. Now our Thai server has support the BDS, GPS, and GLONASS satellite system imports. And we also support some ground source imports, including RFB, TOD, and PTP. If you have several multiple imports, the PTS Thai server also has some mechanisms to negotiate out which is the best import signal, and it will choose the best as the import signal. Besides, we also support the different levels of oscillators here. We can support the OXCO and the Rapid oscillator. The Rapid oscillator has higher holdover performance. And there are multiple outputs based on different models. And we also support the different protocols for the monitoring. And we also support the MMS inside the substation. And next, we can go for the wind farm. So let's see what is a wind farm, what is inside the wind farm. You can see that this is a picture for the wind farm, and there are many turbines. The weather is very nice, and the turbines are installed at the top of the mountain. But sometimes the weather is not very good, and it is wet, and it always rains. And you can see that there are also some fogs here. And it is some picture of the offshore wind farm. And you can see here, if the customer want to maintain this kind of wind farm, they need to ride the boat to the turbine. And here is some environment requirements here. Since in the substation, all the switches are installed in the station rows, but for the wind farm application, the Ethernet switch are installed in the turbine. The turbine do not have many good conditions. It is just installed outside, so it has more harsh environment around. So for the temperature, we should ensure the wide range from -40 to 70 to 75. And you can see just now, the weather is very wet, and and there are also some salt fog, which will cause damage to the PCB inside the switch. So we should paste the anti-corrosion coating on the PCB to avoid the chemistry corrosion. And also, some wind farm, some turbines are installed at the top of the mountain. So we should also ensure the device can work at the high altitude. According to our test, we have supported to work at the altitude of 5,000 meters. Besides, since some turbines are installed at the mountain and there are frequent thunderstorms at the mountain, and the turbine is just like a lightning rod, it will be more possible to be attacked by the lightning. So the ENC level 4 is also critical essential for the devices installed in the turbine. And the following is a solution for the wind farm, is a traditional solution for the wind farm. You can see that this is a requirement from our customer, from our key customer. This network is divided into 3 parts. The turbine network, the substation network, and the remote data center across the internet. Let's start from the turbine network. It is the access level. For each turbine, 2 Ethernet switch is installed. One is installed at the bottom and another is installed at the top of the turbine. The bottom one we selected Second 3000 and 3000 and A, and it has with a model of 4 gigabytes optical ports and 16 gigabytes copper ports. Since we have 4 optical ports, 2 optical ports are used to create the interconnecting links between, for the enable switch, and another one is for the uplink to the top of the switch. So 4 optical ports are essential for the network. And on the substation level, we use a redundant group of core switch, Second 3000, Second 4000 and 432G, and it has 4 10 gigabyte ports and 32 1 gigabyte ports. The 1 gigabyte ports is used to loop the turbine network. And there is a VRP group and the LACP group between these 2 switches. VRP ensure the redundancy of these 2 switches, and LACP can provide higher bandwidth between these 2 switches. And they also form a OSFP redundancy rule between the third-party router for the internet communication to the data center. Besides, there is another key requirement from the customer. Since there are many switches for this wind farm, they want to keep the same setting for the Ethernet switch. If we use some traditional rings, we must set a master within a ring, and others are the slave. But this will not meet the customer requirements, since the configuration for the switch will be different. So in this solution, we provide the DHP protocol. But actually, our DHP protocol also cannot meet the requirements at the first stage, since if we use since according to DHP, these 2 ports connect with the core level shall be the whole whole node, and these are 2 whole nodes. And the switch between these 2 between the whole nodes shall be the normal node. So in this project, we modify the mechanism of DHP, and we put the whole node on the curl switch. So all the access switch will just be the normal node and keep the same configurations, and so that we can keep the same configurations for the button switch. And another requirement from the customer is that they want to, their PLC has another mechanism that he do not want to set the static IP address for the PLC. Their PLC can check the LLDP packet and use the alliance of the LLDP packet to automatically set the IP address itself. So we developed the new LLDP, and we can manually set the alliance segment in the LLDP packet. For example, if I set the alliance on the port 2 to be this IP address, then if I connect the PLC on this port 2, then inside the LLDP packet, it will send this IP address. Then if the PLC receives the packet, it will automatically set its own IP address without manually set the static IP address. So it will save the manpower for the customer. And also we can see that there is a DGA serious gateway here. It is used to convert from the protocols, and it should convert to 104. And another thing, it is not only a gateway, and in this project, we also use the calculation function on the DGA4. Since the customer is using a new generation SCADA system and operation system in this wind farm, but it is not 100% completed, and some points cannot be generated from the turbine directly. So we use the DGA4 to do some simple calculation here. For example, they can update the analog 1 and the analog 2, but they cannot get another point. So we can use analog 1 and analog 2 to do some simple calculation and return a new value, and then update to the remote center. You can see that this is the calculation requirement, and we can do it in the task here, and then update. The following is some introduction about our redundancy protocol. DRP protocol. DRP means distributed redundancy protocol. This is a protocol based on IEC 62439-6. And it has a highlight that the recovery time can be less than 20 milliseconds. And you can see that at the initial status, the router will be automatically selected, and you do not need to configure the router. And there is one block pace on the route. And if there is a link failure here, it will trigger the blocking status on these 2 ports. And then the 2 switch will send the link alarm to the route. Then the route will forward the initial blocking pace and send the ring change to the whole network. Then the whole network will clean the MAC address table and relearn the MAC address. With this mechanism, it can achieve a fast recovery. It can achieve a fast recovery which is less than 20 milliseconds. And you can see here, this is the configuration for DRP. And normally you only need to configure the 4 parameters: domain ID, domain name, and the RIMPORT 1, RIMPORT 2. It's enough. Do not need to create, do not need to manually set the root device. And another highlight is that if you use the DRP protocol, the network will never occur the broadcast stone. Since sometimes even we use recovery protocols, it will still have the broadcast stone. Since, for example, if there is one switch hung for some reason in this ring, and it cannot deal with the redundancy packets, and it cannot control the forwarding and block on the ports, then it will create a loop and generate the broadcast stone. So in DRP protocol, we also have some mechanisms to avoid this kind of failure. The switch will automatically and typically send the link check packet to the neighbor host. You can see that the switch sends the link check packet. And if the switch is hung, it will not reply the link check packet. Then these 2 switches will block the path to this switch, and then isolate the hung switch from the whole network. So there will be no influence on this hung switch for the whole network. And for the WinFund application, we can recommend the following device. On the core level, we can use these 2, 6432G and 3028 GPT. And the first one has 4 10 gigabyte ports for high byte ones for the up layer. And the 3028 GPT is modular design, and you can expand more functions on this switch. And for the access level switch, you can use the 63000A. And actually, 63000A can be used in all the applications since it is powerful on the software and the hardware. And these industry protocols are also supported. And also, we can use the DGA series gateway to do the protocol convert, and also to do the software PLC calculation in this device. And this is another solution for the WinFund, and it's an all-in-one box. You can see there is always a PLC in the wind turbine, and the PLC is connected with the lower level devices. The devices include the environment monitoring, the end device monitoring, and the ventilation, and the electrical monitoring, and the fire alarms. And then it will update the values to the extend ring, and then up layer, and then transmit to the up layer. And we can just replace the PLC and the Ethernet switch with the DigiCon 3000, since it has the Ethernet port, it has the protocol convert, and it also has the digital input and output. And also it supports the soft PLC function, and we can do some programming on the digital input and output. In this case, it can perfectly replace the simple PLCs in the field application. Now maybe we can have a rest.
Коллеги, давайте поотдыхаем.
Next, I will give you some case share. Next, I will focus on the case share. There is an interesting project and network here. This is a solar thermal plant. Maybe most people are familiar with photovoltaic plant, but they do not familiar with solar thermal plant. So here I give a comparison between these two plants. This is a photovoltaic plant here. You can see there are many boards here, and it can directly turn the light energy to the electric energy, but it has some disadvantage since you cannot generate the electric in the night, since due to there is no sunlight in the night, so the energy is not controllable if you use this kind of energy generation. And this is solar thermal plant. You can see it is just something like this, and it is a circle. There are many mirrors inside the circle, and there is a tower at the center, and the mirrors will always calculate out best angle to reflect the sunlight to the central receiver, and the central receiver will transmit the heat to the hot salt tank, and then the hot salt tank will heat the steam generator, and the generator will then the steam generator will drive the turbine generator, and then generate the electric energy. And this is controllable for the generation, since you can stop the heat transmission on the hot salt tank, and you can also start it in the night and generate more energies if required. Since the heat energy is easier to store, so it is controllable, and the energy transmission is from the light energy to heat energy to the electric energy. And this kind of plant is always built at the Gobi and the desert area, since these areas have long-term sunlight and more sufficient sunlight energy. And here you can see there are some pictures here, and these are all the mirrors, and they will reflect the sunlight to the centralized tower. And since these areas are remote areas and in the Gobi and the desert, so the temperature it has a wide range of temperature, and you can see that it is the first day I arrived there. It's -6 to 6 degrees, but several days later, it dropped to -18 degrees. It has wide temperature range at that area, so the device installed there should also resist this kind of should resist the temperature wide temperature range. And the network is divided into two parts. The first one is video surveillance network. You can see that this network is simple and just connect the cameras on the access switch, and the access switch connect with the concentration switch, and then update to the control level switch, and there will be a video surveillance server connected on the control switch. Just finish the low layer to up layer updating. And for some remote area cameras, we can use we can use the medium converter to convert from copper signal to the optical signals and finish the updating. And another network is control network. You can see here is a topology. At that project, there are 15 mirror plants. You can see just there are 15 plants like this in that plant. And there are 15 years and 15 years. And first, the controllers will be connected on the access level switch, and then the access level switch has two links for the concentration switch, and each concentration switch has another two uplinks for the core level, and then the server is also connected on both of the core level switch. And you can see access level, concentration level, and the core level. And dual homing link uplinks for the up layer. And this one also has dual updates, dual uplinks to the core level. And on the core level, there are two Silicon 6448G to form a redundancy group here. So it will just like this one. And one will be active, one will be activated, and another will be non-activated. And at the core level, we use the 2U unit switch. And at the concentration layer, we use the Silicon 3028 GPT. And at the access layer, we use the Silicon 3000A. And you can see at the core level, we use the VRP protocol to provide the redundancy routing. And in this network, it ensures the high performance of redundancy, since each device all has two uplinks for the up level. If there is some switch failure here, if the one concentration switch is failed, the access level can find another path to another concentration switch and finish the recovery. And the recovery time will be less than 20 milliseconds. Just now it is a device failure, and we should also take consideration of link failure here. If this link is failed, and it will still go through this first concentration switch, but for the concentration, for the communication between concentration and core level, it will switch to another update links. It will change to this page. It will change to this page to the server. Since it is a critical big project, so the customer wants to pretest all the solutions in the lab first, and the test lasts for 1 year, and all the switch is installed in the laboratory of the customer, and you can see that here. Around 300 switch are installed in a room and connected to form the rings. The optical fibers are used to form the link between the switch, and the copper ports are used to connect the controllers. And each switch is connected with 5 controllers. And this is the last test. You can see that there are LED indicators on the controllers. The LED indicators can indicate if there is packet loss with the servers. Actually, in this test, there is something wrong. And since the customer wants to do the load test and the pressure test, so normally the packet exchange is just 1 packet per second. At that test, they raise the load to 50 packets per second for each controller. There are 1,000 controllers in this network. So there are 50,000 requests and replies in this network if they do that pressure test. And finally, we found that several devices, several controllers have the packet loss in the network, and we do the troubleshooting here. And finally, we found that it is something related to the boundwise and the network design. So since you can see that these optical fiber ports are for the downstream links, and this copper port is for the uplink ports for the server. Both of these ports are using the 1 gigabyte ports. It means that same boundwise for the low layer and the up layer. And for the down layers, there are 16 ports. For the up layer, there are only 1 port. So it means all the flows from 16 downstream ports will be concentrated on 1 single port if they want to communicate with the server. So it caused the congestion at this port. Finally, we found 2 solutions for this problem. One solution is that we can use the 10 gigabyte port for the server, but this is rejected by the customer since their server do not support 10 gigabyte port, 10 gigabyte speed. So we use another solution, and we use the link aggregation. We use the link aggregation here and use another copper port to form link aggregation group here. And in this way, we can expand the uplink boundwise for the server. And you can see here, for the core layer to the server, we add 1 more link and create the link aggregation here. And on the server, we use the Tini to support the load balance with the core layer switch. After we do this configuration and this packet loss problem is fixed. In this network, the most highlight is that all over the network, there is high redundancy, high redundancy performance, which can be less than 20 milliseconds. And next, we will continue to the oil and gas solutions. And the first project is China and Russia oil pipe. This project is starts from 10 years ago. And actually, this network is very simple. It is divided into several areas. And you can see for each area, the end devices have two service ports, one for LAN A switch and another for LAN B switch. And also for the switch, it has two uplink ports. One is activated and another is blocked, to the third-party router. And the communication network is based on the existing providers. And with this communication network, different areas can communicate with each other and then update to the core layer. And this is some photos. This is the pipeline from Russia to China. And this is some pictures. And in winter, it is very cold since it's across the cold areas. And here, till now, it has been 10 years continuously running in the harsh environment. And another project is the gas processing plant project in Uzbekistan. And in that project, we provide the Silicon 3028 GPT and the Silicon 3000 as the layer 3 switch. And the layer 2 switch, we use the Silicon 3024P. And we use another DGA6 to act as a serial server. And also the median converters. The highlight is that from FAT in ABB Czech Republic to the network validation, all these jobs are done by KYLAND engineers. And we also finished the configuration for the ABB AFS switches. Here is some pictures for the project. And here is some pictures in the night. And here is some photos for the cabinet. You can see here is ABB switch, and here is our KYLAND switch. And the top three are the Ethernet switch, and this is the serial server DGA6. And this is the minutes of meeting. On the meeting, the customer showed us the configuration details for all the switches. This is the architecture of the network. Since you can see in this network, there is not only KYLAND switch, but also some ABB switch. So we cannot use the private redundancy protocol. We cannot use DRP, we cannot use DT-ring. We can only use the public redundancy protocols. We can only use STP, RSTP, and MSTP. But in this network, we cannot use the most common used RSTP since the network is very big and they are connected with each other. RSTP only allow at most 50 nodes in a single region. So in this network, we can only use the MSTP to cooperate with the ABB switch. With MSTP, it can get redundancy performance on the different VLANs. We just need to ensure we just need to limit the quantities in a single VLAN, and it can get a high redundant performance. And this is the topology of the network. The network has 4 layers, and the the top layer is 2 core levels layer 3 switch, and it is in the control center room. And there are another 3 regions. All the 3 regions are installed with true redundancy group of layer 3 switch. So there are 4 VRP groups here. And for each VRP group, they are also connected with additional layer 2 network. You can see that these networks in this area are connected on these two layer 3 switch, and trunk different VLANs and update to this redundancy group. And in this switch, within this switch, they are all RSTP based redundancy, and including the ABB switch. And we also finished the configuration on the ABB switch. And here is some photos at the on-site. And this is a recognition letter from the customer. Since in this project we met many problems, and the customer wants us to finish all the jobs in a short time, and so we need to work day and night to meet the requirement. And finally, it is successfully commissioned on time. So the customer gave us the recognition letter. Okay, thank you.
Thank you very much, Stark. Thank you for your training. Thank you for your presentation. Коллеги, теперь вопрос-ответ. Пишите, пожалуйста, свой вопрос, как вчера. Будем рады ответить. Можно на русском, можно на английском. Привет, коллеги. Коллеги, стеснялся. Конечно. Спасибо. Сегодня мы загружаем записи видео, презентации и вчерашние, и сегодняшние в онлайн-диск. И также загружаем презентации в онлайн-диск. И вчера я вам обещал, что еще дать скриншот насчет подключения через KYLAND со сторонним виндором. Также загружаем. ссылку мы потом отправляем вам всем на почту. Конечно. Задавайте, пожалуйста.他问我们有没有类似于 MRP 的这种协议。
DRP. NRP is described in IEC 62439-2, and we have another protocol comply with IEC 62439-6 named DRP, Distributed Redundancy Protocol. Besides, we also support NRP on some of our switch. Sequence 3008 can support NRP, and Sequence 3024P also support NRP. We have licensed software. The KView is just licensed software, but we have no plan for the licensed protocols for the switch. All these functions are usable on the switch.
Пока у нас деньги еще хватает на разработку и так далее, так что лицензионный протокол пока не думаем. Коллеги, у кого еще вопрос? У нас тут есть один функция в Zoom. Вот. Тут можно поднять руку. Вам спасибо за то, что вы выделили время на участие нашего тренинга. Всем спасибо. Так, 5, 4, 3, 2, 1. Сейчас. Мадяр, 这个你说一下这个вебинаре вы упоминали.
Дискретными входами и выходами. Вопрос немного непонятно с дискретными входами и выходами. Это DOIO, да, имеется в виду?
Коллеги, если что, вы можете включить звук. Можно свободное обсуждение.
Старк, 他的意思是这样的，你在那个就是培训过程中跟他们说，我们有一些交换机，就是支持那种接口 DOI， 然后那个 IO 那种，然后他的那个这些接口能不能给他提供一些信息？我们的那个逻辑怎么编，那个程序我们怎么写？他是大概是这个意思吧？啊。
Stark， 我们有这个可以提供吗？有这样方面的信息吗？
可以。
有英文的吗？
有英文 ，DigiCon 3000。
Я так понимаю, что это Юрий задал вопрос, хороший вопрос. Да, конечно, мы предоставляем информацию насчет программирования. Мария, прошу записать, пожалуйста, вопрос Юрия. Юрий.
Хорошо, я сохраню. Stack 你可以恢复了，跟他大概这个。
就是这个产品吗？
对这个产品，然后
这个产品
用这个英文的
Андрей, все понятно.
我得去问耀耀。
Юрий, мы отправляем вам после презентации только информацию на английском языке.
Спасибо. На английском будет нормально.
Окей. У кого еще вопросы? 5, 4, 3, 2, 1, 0,5, 0. Коллеги, спасибо. Спасибо. Вам хорошего дня. До свидания. До свидания. Старк, на 今天就到这里。
行。
Спасибо. 等他们都出去。